Welcome to this explainer. Okay, today we are diving into a pretty shocking default setting in Kubernetes. We're going to learn exactly how to lock down a 3-tier web application, taking it from a totally wide open, vulnerable cluster straight to a secure fortress. And we're going to do this using Kubernetes Network Policy and an incredibly powerful tool called Cilium.
So, here's our roadmap for this transformation journey. We'll start by looking at that default danger, break down the actual anatomy of the problem, explore our specific tool set, figure out ingress and egress, walk through a 6-step journey, and finally, check out our secure final state. All right, part 1, the default Kubernetes danger. Imagine a standard online shop architecture split into 3 tiers. You've got a front-end pod running on port 80 that shows the actual web page to your users. Behind that sits your backend API on port 8080. That's what processes requests and talks to the data layer. And finally, you have your Postgres database on port 5432, which stores all your highly sensitive data. Orders, users, products, the whole shebang. But pay close attention here because we also have an attacker pod. This simulates a bad actor who has somehow managed to get inside the cluster.
And here is the absolutely terrifying truth about this standard setup. Right now, right out of the box, Kubernetes gives every single pod a direct network path to every other pod. There is no firewall, there are no rules, 0 restrictions. This means our attacker pod is literally already inside the house, and the doors are wide open. They can talk to any part of our application without facing a single roadblock.
Let's move to part 2 and break down the anatomy of this problem.
Now, you might be thinking about your own architecture right now. You might be saying, well, my namespaces or my Kubernetes services are protecting me from this kind of internal threat, right? But let me ask you a very direct question. Is a Kubernetes service actually a firewall?
No, absolutely not. A service is literally just a routing rule. If anyone can reach the service IP, they can reach the pod behind it, period. And what about namespaces? Separating dev and prod into different namespaces gives you absolutely 0 native network protection. It just organizes resources. Because of this, our attacker can completely bypass the front end, hit the internal API, or, even worse, initiate a direct connection right to our database and read or write whatever they want.
Okay, moving to part 3, the tools we need to fix it. To actively enforce our security rules, we're going to bring in a seriously powerful tool called Cilium. Cilium operates as our Container Network Interface plugin, or CNI. It uses a blazing fast technology called eBPF, right down in the Linux kernel, to natively control and observe traffic at the network level. This gives us incredible performance and, this is the crucial part, the ability to do advanced Layer 7 filtering.
Think of this as our complete security tool belt. We use standard Kubernetes network policy to control basic, broad, pod-to-pod traffic, basically who's allowed to talk to whom. But then we take it up a notch. We use a Cilium network policy to give us Layer 7 filtering. That means we can actually dictate the exact HTTP method and path allowed, like saying a pod can get data, but absolutely cannot post data. Finally, we use a Cilium network policy with 2 FQDNs, which lets us control outgoing traffic to a specific external hostname, instead of relying on an unpredictable IP address.
Which brings us to part 4, locking ingress and egress.
I want you to imagine every single pod in your cluster as a room with 2 distinct doors. You've got one door strictly for traffic coming in, that's ingress, and you have a completely separate door strictly for traffic going out, that's egress. So when we want to secure our cluster, the very first step is always to apply a default denial all policy. Think of this as instantly slamming and locking both of those doors on every single room in the building. So once we've locked all the doors, we have to selectively and very carefully unlock them based strictly on what the application actually needs. Take the front-end pod. Nobody internally calls the front end, so its ingress door stays locked. But it needs an egress door open to send requests to the backend. Now the backend API is the middleman. It needs its ingress door open to hear from the front end and its egress door open to speak to the database. And our Postgres database, it only needs its ingress door open to receive connections from the backend. A database should never, ever initiate a call out to anywhere, so its egress door remains permanently bolted shut.
All right, part 5, let's walk through our 6-step journey.
We are systematically moving from danger to security here. Step 1, we prove the vulnerability exists by observing that default open network. Step 2, we take drastic action. We apply that default deny all, locking both doors on every pod. Step 3, we meticulously allow only specific required ingress and egress paths between pods. Step 4 is where we apply those advanced Cilium Layer 7 policies to lock down HTTP methods. Step 5 brings in Cilium's FQDN policy to safely allow external egress by hostname. And finally, Step 6 is rigorously verifying our perfectly locked down rock-solid state. And finally, Part 6, the secure final state. The contrast here is literally night and day. We went from a terrifying before state, basically an open playground where any pod can talk to any pod, cross namespace traffic flowed freely, and an attacker could just stroll right in and read the database. But look at the after. It is a strictly enforced one-way street. Only the exact chain front end to back end to database is open. Direct database access from anywhere else is explicitly blocked. And most importantly, the database absolutely cannot leak data out to the internet. Now, as you review your own cluster security strategies, I want you to remember this golden rule from our explainer today. Locking the door out is just as critical as locking the door in. Honestly, so many organizations completely obsess over who can get into their pods, but they forget that data exfiltration happens on the way out. Standard Kubernetes network policy really struggles here because it can't easily allow egress traffic by a hostname. But as we've seen, Cilium's FQDN policy handles this elegantly and safely. I'm going to leave you with a bit of a provocative thought today. I want you to take a hard, honest look at your Kubernetes environment right now. If a bad actor compromised your cluster today, are your network outdoors truly locked? Or could your database silently leak your most sensitive data straight out to the internet? Trust me, it is time to go check those doors. Thanks so much for joining me for this explainer.
Master DevOps and cloud computing. Transition into DevOps and structured path track your path forward. And structured path for class.